So, what does it really take to build a modern marvel, a true giant of the seas? We're not talking about just any old ship here. We're diving into a revolutionary class of vessel, one that was designed from the ground up to reshape global trade. This is an absolutely incredible story of engineering, ambition, and ingenuity. Let's get right into it. First, to really get your head around the scale of this project, you have to understand the scale of sea travel itself. A whopping 90% of everything traded internationally, yeah, I'm talking about your phone, the food you eat, the car you drive, it all travels by sea. It's just staggering. That means right now, something like 40,000 cargo ships are crisscrossing the globe, keeping our world running. For decades, the name of the game in shipping was simple: just build bigger. But we've kind of hit a physical limit. The biggest ships today literally can't fit through some of the world's most crucial canals. So if building bigger isn't the goal anymore, what is? Well, the new race, the real competition, is all about efficiency and sustainability. Okay, so here's how we're going to walk through this incredible journey. We'll start with the grand challenge they were facing, then look at the blueprint for this behemoth. We'll see how it was built in pieces, get to know its giant heart, and follow it from steel all the way to the sea. And finally, we'll look at why it's truly a masterpiece of ingenuity. All right, our story really kicks off with the French shipping company CMA CGM. Their goal wasn't just to build another ship. No, they wanted to build the world's largest and most eco-friendly vessel. But honestly, the most audacious part of their whole plan, it was the timeline they set for themselves. It was, it was basically impossible. And this slide really lays out the insane challenge they were up against. I mean, look at this. The old way of doing things was just thrown out the window. The new goal was to build not one, but 9 of these massive ships in just 2 years. That's a timeline that would normally produce just a single ship, maybe. And if that wasn't enough, they also had to run on a cleaner, much more complex fuel, liquefied natural gas. So, just how big are we talking here? Let's break down the dimensions of this new class of ship, because the numbers are truly, truly staggering. First off, the length: 400 meters. To give you a mental picture, that's like laying 4 football fields end to end. This is a vessel so long it would absolutely dwarf many of the world's most famous landmarks. And what about its weight? Now get this. This is completely empty 70,000 tons. That's the same weight as 7 Eiffel Towers. Or, if you prefer a different visual, it's like weighing over 11,000 African elephants. And the cargo it can carry? A mind-blowing 23,120 standard containers. If you were to line all of those up, just one ship's worth, they would stretch for 150 kilometers. It's just hard to even imagine. So, the big question is, how on earth is it possible to build 9 of these giants in just 2 years? Well, you have to completely abandon the traditional way of building a ship from the keel up. The solution is absolutely ingenious. You build them in pieces. This is the magic of what's called modular construction. The shipyard, which is literally the size of a small city, precision cuts these enormous steel sheets. Then they're assembled into huge blocks, and some of these are as large as multi-story buildings. All the wiring and plumbing is pre-installed, and then like giant Lego bricks, these massive blocks are welded together to form the ship. And the technology behind this is just wild. Each ship needs over 12,000 of these steel sheets. So to cut them with perfect precision, they use a laser beam that burns at 18,000 degrees Celsius. That is 3 times hotter than the surface of the sun, and it slices through stick steel like a hot knife through butter. And then, of course, you have to weld all those pieces together. The total length of welding on just one of these ships is 1,250 kilometers. To put that into perspective for you, it's like welding a continuous line from the southern coast of Pakistan all the way up to Lahore in the northeast. Incredible. So, building fast was one massive challenge, but building clean was a whole other beast. And that brings us to the ship's heart, its revolutionary fuel system, designed to run entirely on liquefied natural gas, or LNG. Now, switching to LNG is a total game changer for emissions. I mean, compared to the traditional heavy fuels these ships usually burn, it sloshes sulfur dioxide by 99% and cuts overall air pollution by 91%. Plus, it reduces CO2 emissions by a really significant 20%. This is a huge, huge step towards cleaner shipping. But of course, there's a catch. To keep natural gas in its liquid form, it has to be stored at an unbelievably cold temperature, minus 161 degrees Celsius. If it gets any warmer than that, it instantly turns back into a highly volatile gas. That would be, well, a catastrophic failure out on the open ocean. So, how do you keep something that cold on a massive ship that's crossing warm oceans? Simple. You build the world's largest thermos. I'm not kidding. This enormous insulated fuel tank is so vast, it could hold the water from 6 Olympic-sized swimming pools, keeping almost 20 million liters of LNG perfectly chilled. And I love this part because it perfectly shows this blend of high-tech and, well, simple, brilliant low-tech. To test for microscopic leaks in this incredibly advanced tank, workers used a classic method. They just applied soapy water to the joints, created a vacuum over it, and watched for bubbles. It's simple, it's effective, and it's absolutely critical for safety. Okay, so the hull is assembled, the high-tech fuel tank is in place, now it's time to install the powerhouse, the massive propeller, and the brain of the whole operation. This is where the mountain of steel starts to feel like a real ship, ready for the sea. At the very core of the ship is the largest natural gas engine ever built. This thing stands as tall as a 6-story building. It weighs over 2,000 tons and cranks out 85,000 horsepower. In fact, just its crankshaft, the part that actually transfers all that power, weighs 220 tons all by itself. And this incredible sense of scale applies to every single component. Just take the anchor chain. A single link in that chain weighs 300 kilograms. The entire chain weighs as much as 60 adult elephants. Every single piece of this vessel is its own massive feat of engineering. After a year and a half of absolutely relentless work, the very first ship was finally ready. Now it was time for the sea trials, the final, most grueling tests to make sure this masterpiece of ingenuity was truly ready to conquer the world's oceans. And after 15 days of the most rigorous testing you can imagine, from emergency stops to complex navigation checks, the ship passed with flying colors. But the real story here isn't just about steel and technology. It's a testament to the incredible collaboration and tireless dedication of 6,000 workers from all over the world who came together to make the impossible happen. In the end, the shipyard didn't just meet the deadline. They beat the clock, delivering all 9 ships and launching a brand new era of cleaner, more efficient shipping. These vessels are living proof that when human ambition meets human ingenuity, we can literally move mountains. And it just makes you wonder, doesn't it? What other challenges that seem impossible today are just waiting for a new way of thinking?